Hey folks, I've put the key, a PDF of the key for the lab quiz over sections 10.1 to 10.3 in the assignments area of Blackboard, but I wanted to take a little bit of time here to go over a few items to clean up some misconceptions and some issues that I saw when grading the lab quiz, so you get these under control and don't continue to make them going forward. I don't have anything really to say about number 1. Did a great job on 1. Number 2, write an expression for the nth term of the sequence. I think everyone got that. There may have been a couple that missed B and C, but hopefully you can see what B and C is. Number 3, here's where we started to have some issues. Folks, the directions are determine the convergence or divergence of the sequence with the given nth term. If the sequence converges, determine its limit. These are sequences we're talking about. So in A, you were given the sequence A sub n equals 4 minus 3 over n. To determine if a sequence converges or diverges, you have to do the limit as n goes to infinity. Well, the limit as n goes to infinity of 4 minus 3 over n is just 4. So that sequence converges. Likewise, with B, it really jumped out for C. For some reason, a lot of you, you started to look at these as series. These are not series. These are sequences. Does the sequence converge? So A sub n equals 3 to the n over 4 to the n, which I can rewrite as 3/4 to the n. It's just the sequence 3/4 to the n, not the series. So the limit as n goes to infinity of 3/4 to the n, that limit is 0. The sequence converges. Likewise in part D, the limit as n goes to infinity of the sequence 1 plus k over n to the n. That limit is e to the k, so the sequence converges to e to the k. And by the way, that's a limit you're going to start to see pop up more and more often that I recommend that you know. Likewise in E, most of you did a good job of recognizing that we were utilizing the squeeze theorem here to get the limit as n goes to infinity of sine n over n to be 0. And then for F, again, it's a sequence, but you know, n plus 1 factorial over n factorial, that simplifies to n plus 1. And then the limit as n goes to infinity of n plus 1 is infinity. So the sequence diverges. So make sure you understand the difference between a sequence and a series. See, number 4, determine whether the given sequence is monotonic. So for 4a, I wrote down like the first 4 terms of the sequence. That's not enough to say that it's monotonic. You can't just write down some terms and say, yep, that's good, it's monotonic. You have to show that it's monotonic. So when I look at the terms, I only wrote down 4 terms. 1, 3/2, 9/5, 2. It looks to me like those terms are increasing. And that's monotonic increasing. So that means a sub n has to be less than a sub n plus 1. That's what it would mean for monotonic increasing. And then, you know, I can go through the algebra. You know, a sub n is 3n over n plus 2. A sub n plus 1 is 3 times n plus 1 over n plus 1 plus 2. And then, you know, you can see the inequalities I get. Multiplying by the LCD, I end up with that true statement, 0 is less than 6, which tells me if I just reverse my steps, yes, it is monotonically increasing. For B, I have the sequence n e to the negative n. I can't come up with algebra like in part A to justify anything. So what I do is I look at the function of the reals. F of x equals x e to the negative x. That function of the reals, x equals, or x e to the negative x, is identical to the function of the positive integers, n e to the negative n. They're exactly the same. So whatever the behavior of the function of the reals, f of x is, the function of the positive integers, a sub n, it has to have the exact same behavior. It's along for the ride. So I compute the derivative of x e to the negative x. And the derivative is e to the negative x minus x e to the negative x. And then I factor out an e to the negative x. And I see the only critical value would be x equals 1. So if I made a sign diagram, I'd be putting 1 on there. I don't care what's happening to the left of 1, because numbers to the left of 1 are not positive integers. I only care what's happening to the right of 1. And to the right of 1, well, the derivative is always negative, which means the function is always decreasing. And if the function of the reals is always decreasing, that means the function of the positive integers, a sub n, it too is decreasing. Now let's talk a little bit about number 5. Folks, just pay attention to the directions. Follow the directions. Determine if the following series converge or diverge. State a reason and show enough work to convince a Michigander. Determine if the series converges or diverges. So, I mean, you have a 50-50 chance of being correct, saying converge or diverge. It's the state a reason and show enough work to convince a Michigander. That's where the real action is here. So when I look at 5a, I immediately say that's a geometric series. R is equal to 2/3, which is less than 1. Series converges. So I've determined that it converges, and I have my reason there. It's a geometric series. R is 2/3, which is less than 1. For 4b, I just rewrote the series using rules of exponents as the series 3 times 4/7 to the n. Once I rewrite it like that, I see, hey, it's a geometric series. R is equal to 4/7, which is less than 1. It converges. For 5c, we have the series 3 e to the negative n, which I can rewrite that as 3 times 1 over e to the n, which I can rewrite that as 3 times 1 over e, all that to the n power. And by doing that, I can see, yes, I have a geometric series. R is equal to 1 over e, which is less than 1. Therefore, it converges. Whereas with D, it is a geometric series. R is negative 4/3. Since the absolute value of R is greater than 1, I know the geometric series diverges. So pay attention to everything that I said here, and look at the key carefully. You need to have this idea of that's what I'm going to be looking for, especially as we move on for studying more series, more tests, and using different tests to determine if a series converges or diverges. So that's it. I just wanted to do a quick go over of the lab quiz. All in all, not too bad. I hope everyone's doing well, and I hope you're getting some value out of the videos. Thanks for watching.